Hello, I'm John Walker. I'm a professional development leader at the National Science Learning Centre, and today I'm going to show you how to make a stop motion animation. Stop motion is the technique where you use lots of still photographs and stitch them together in a continuous sequence so that it looks like the action's moving. So you'll be familiar with TV programmes like Bagpuss and Wallace and Gromit, and of course in old horror films it was used to make monsters like this move. So why might you want to use stop motion animation in a science lesson? Well, there's lots of scientific processes which students could animate to demonstrate their understanding to you. And of course this is a good thing to do because you want to know what their understanding actually is. Now normally when you wanted to do a stop motion animation you'd have needed quite a lot of sophisticated equipment. But these days we can actually do it with something like a smartphone or an iPod Touch or a tablet. So I'm going to be using an iPad here, and I've chosen something fairly simple just as an example of what we can animate. The first part is to plan what you want to do, and there are a number of things to think about in the planning stage. So first of all I have to try and visualise what I want to actually produce, and I have to think about how long it's going to be, for example. Then I can think about how many individual frames do I need to shoot, and how much do I need to move my little pieces of props by each shot. You need to make sure that you control the movement of virtually everything if you want your animation to look half decent. So for example, the iPad will be taking the photographs, so it's important that you don't move the iPad, otherwise you'll end up with action that looks quite jerky. It's also important that you don't move any lighting, because otherwise your animation might end up looking a little bit flashy with the lighting changing from one position to another. So I'm just about ready to start. I've set up the thing that I want to film over there, and I've clamped the iPad to keep it really still. I'm using an app which is a free app called Timelapse, and on Timelapse I can choose what I want the frame rate of playback to be, and I've chosen 12 frames per second. That means for every 1 second of footage we watch afterwards it requires 12 still frames or pictures. Now that's a little bit jerky actually, but there's a trade-off in terms of quality and how much time and effort you want to spend on this. Okay, I take the image simply by pressing the screen, just touching the screen. So I'm just about ready to go. So my action's going to be over here, and I've chosen to animate a chemical reaction showing how the chemical bonding changes when methane and oxygen react together. I've also got some labels to put on here with words on, and I want to make sure that in the finished product people have got time to read the words. So that means I have to think about how many frames I need to allow for the labels too. I reckon it's going to take just over a second for people to read a label, so I'm going to need about 12-ish frames per label. So here's what I'm going to animate, and I have in mind that I want to make this about 4 seconds long. So I'm using 12 frames per second. That means I'm going to need to use 48 frames. So I've got to think about dividing my action from start to finish into 48 sections. This is where it starts. It's going to finish down there. So in between I'm going to try and do 48 different sections. That's quite a lot actually, but I'm only going to move them a little bit each time. And each time I've moved them a bit, I'll come round here, just touch the iPad screen, and it will take another frame. So I'm going to start with everything like this. So there's the first frame. What I'm going to do now is move stuff a little bit. done. So I've used a few more than 48 frames here. I've used 54 actually. Once I've finished taking all the frames I want, then I press stop/save here, and what this does is it converts my files into one video file, and it will store it on the camera roll of the device. So I'm ready to have a look now. Okay, so here goes. Not bad. Okay, so it doesn't really matter whether students get the science a little bit wrong if they're making their own animations here, because of course what we want them to do is learn where they've gone wrong, and this technique is a way of making their learning explicit. So I hope I've shown you how straightforward it can be and that you might want to give it a go.